Hello students, welcome to day 44 of 99% in 99 days for your class 10th boards. So today we are going to discuss the most expected questions from the chapter carbon and its compounds. Okay, so we are going to discuss many important and different types of questions. So please watch the complete video. Now let's go to the in this session what you will be getting 3 MCQs and some 2 marker 5 questions, 9 questions of 3 markers and 12 questions in 5 markers. Okay, so now let us see the first question here, that is your MCQ. When sodium hydrogen carbonate is added to ethanoic acid, a gas evolves. Consider the following statement about the gas evolve. It turns lime water milky. Yes, we know carbon dioxide gas, so this statement is definitely correct. It is evolved with a brisk effervescence. Yes, that is also correct. It has a smell of burning sulfur. That is not correct. It is also a byproduct of respiration. Yes, carbon dioxide is a byproduct of respiration. So we have A, B and D, right? So that is option number D here. Next assertion: in a homologous series of alcohols, the formula for the second member is C2H5OH and the third member is C3H7OH. The difference between the molecular masses of the two consecutive members of a homologous series is 14U. Okay, so yes, assertion is correct, reason is its explanation, so correct answer is option number A. Next, following are the members of the homologous series CH3, CH2, CH2, CH2H. A series of compounds with same functional group but differing by CH2 units is called homologous series. Yes, that is also correct here. So both assertion and reason is the explanation. So option number A is the correct answer. Next, carbon prefers to share its valence electrons with other atoms of carbon or with atoms of other elements rather than gaining or losing the valence electrons in order to attain the noble gas configuration. Give reason. So here if you know that carbon has either it has the tendency, it can gain 4 electrons, right? So what will happen if it has if it gains 4 electron to get that octet rule satisfied? But in that case what will happen, it would be really difficult for the nucleus with 6 protons to hold on 10 electrons. Then what can be the other way? Carbon can lose these 4 electrons, right? But for losing these 4 electrons we need more energy, right? A huge amount of energy will be needed, so that is why that is also not possible, and hence the carbon solves this problem by forming covalent bonds or by sharing of electrons. Okay. Next, question number 2, write the chemical formula of 2 consecutive homologous of organic compounds having the functional group of OH, and what happens to the boiling point and the solubility of organic compound of a homologous series as the molecular mass increases. Okay, so the 2 members you can see we have CH3OH and the next member is ethanol, that is CH3CH2OH. Now if the mass increases, then what happens to the boiling point? Boiling point depends on the mass, so if mass increases, boiling point will also increase, but solubility will decrease, right? So if the boiling point solubility decreases with the increase in the molecular mass. Okay, now let us see the next question. Name the write the name and draw the structure of a saturated carbon with 4 carbon atoms and write the number of single bonds and present in this compound. Okay, so you can see the saturated carbons with 4 carbon is called as butane. Okay, and now if I draw the structure of butane, it is like this. Okay, so you have like this. Okay, so this is the structure of butane, and how many sigma bonds are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so you will get 13 sigma bonds. Next question, consider the carbon compounds having the molecular formula C3H6, C3H8, C4H6, C6H6 and C6H12. Okay, state the number of double covalent bonds present in C3H6. Okay, so question is saying in C3H6 how many covalent double bonds are present. So if I draw the structure of C3H6, right, so you can see the structure of C3H6 is like this: 1, 2, 3, 4, 5 and 6. Okay, so number 1. Next, write the formula of first member of the homologous series to which the carbon compound C4H6 belongs. Now if you see C4H6, right, it is CnH2n minus 2. right? So if the first member means it should be C2H2, right? That is C2H2 because the general formula is CnH2n minus 2. Next question is which one of the above compounds form ring structure of carbon atoms? That is your benzene. C6H6 forms ring structure. Next you have identify which of the above compounds is a member of alkane series. So for alkane, what is the general formula? CnH2n plus 2, and I can find here C3H8, C3H8, 3 2 is 6 plus 2 8. So that is option number D here. Okay. Fine. Next question number 5. List 2 chemical properties on the basis of which ethanol and ethanoic acid may be differentiated and explain how. Okay. So 2 chemical properties, first of all, is ethanoic acid reacts with sodium hydroxide to give you sodium salt and water, but ethanol does not show this reaction. Okay. Next one is ethanoic acid reacts with sodium carbonate, that is NaHCO3, or sodium bicarbonate and gives sodium salt of ethanoic acid, water and carbon dioxide, but that is not found in your ethanol. Okay. Next is question number 6, and sorry, we'll now go to 3 marker questions here. So name the functional group present in these compounds. So you can see here the functional group is aldehyde, and here also the functional group is aldehyde. Write the general formula of the groups of this functional group. Okay. So you can see the general formula for aldehyde is CnH2nO. Okay. You can see if I have 3 carbon, then I am having 6 hydrogen. If I am having 2 carbon, then I am having 4 hydrogen, right? So that is why CnH2nO. Next is write the general formula of the compound of this functional group, that is written. Now state the relationship between these compounds and draw the structure of any other compound having similar functional group. Okay. So what is the relation between these compounds? These are your homologous compound. You can see there is a difference of just CH2 group. So you can write it forms a part of the homologous series of the aldehydes, as these compounds differ by only CH2 unit. Okay. Now if I want to write another member, the 4th member in this series, so that will be 1 2 3 4, 8 hydrogen, 1 2 3 4 5 6 7 8, and double bond oxygen. Okay. Fine. Now let us go to the next question number 2. Draw the electron dot structure of ethine. List 2 differences between the properties exhibited by covalent and ionic compounds. Okay. So ethine structure, you can see there is, the structure is like this. Okay. So you can see here carbon hydrogen bond, and 3 bonds between the carbon atom. And difference between ionic and covalent compound. So they have, ionic compounds have high melting point, covalent compounds have low melting point. They are formed by the transfer of electrons, and they are formed by the sharing of electrons. Okay. Next is question number 3. 2 different forms of carbon, that is diamond and graphite, have different structure and very different physical properties, even though their chemical properties are same. Explain why. So that is because of the difference in the bonding in carbon, in graphite and in your diamond, right? So we have to write that part. 1 second. Yeah. So you can see diamond and graphites are the allotropes of carbon. So first you can explain the diamond part. So diamond is a giant molecule of carbon atoms in which each carbon atom is bonded to 4 other carbon atoms, forming a rigid 3-dimensional structure which is responsible for its hardness. Okay. And if you compare our graphite consists of a layer structure in which each carbon atom is bonded to 3 other carbon atoms in the same plane, giving a hexagonal array. Okay. So if you remember, graphite structure was like this, right? You can draw like this. Okay, this was how was the graphite structure. Okay. Next is question number 4. 1 second. Yeah. So now this question is 3 ml of ethanol is taken in a test tube and warmed gently in a water bath. A 5% solution of alkaline KMnO4 is added to drop by drop to this solution. Then how is 5% of KMnO4 is prepared? So 5% KMnO4 is prepared by adding 5 gram of KMnO4 in 100 ml of the solution, right? So the first part is this one. So by dissolving 5 gram of KMnO4 in 100 ml of water. Next, state the role of alkaline KMnO4 in this reaction. What happens if it is added in excess? So it is an oxidizing agent, right? So it is oxidizing alcohols to ethanoic acid. So Alkaline chemophore acts as an oxidizing agent as it adds oxygen to alcohol and convert into an acid. So till the alcohols were there, if you add this chemophore is purple in color, right? So if you add chemophore till alcohols are there, it will, the color of that pink will be like vanishing because it is reacting with alcohol. But once all the alcohol is finished, if you add excess amount of chemophore, the solution will become deep pink in color. Okay, so initially when we add potassium permanganate, the purple color of the alkaline potassium chemophore disappears. This is because the colored manganate ions of alkaline chemophore is used up in the reaction. But when an excess of chemophore is added, color does not change because there is no more alcohol left for the reaction. Okay. Next, give a proper reaction to explain. So I will write the reaction between ethanol and chemophore here. So it is like this. Okay. You will get, okay, clear, ethanol to ethanoic acid. Next is draw the structure of ethanol and ethanoic acid. Why is the conversion of ethanol to ethanoic acid considered as an oxidation reaction? Write the oxidizing agent in the reaction involved. Okay, so ethanol is C2H5OH or CH3CH2OH and ethanoic acid is CH3COOH. So if you want to write the structure, it is like this: CH3 CH2OH. Okay, this is ethanol. Now if I want to write ethanoic acid, so it is like this: CH3 COOH. Okay, ethanoic acid. Now coming to why is it called as an oxidation reaction, you can see there is one oxygen extra added. So addition of oxygen is oxidation. And what is this oxidizing agent? Chemophore. Okay. Next is, what is homologous series of carbon compounds? Give an example and list 3 characteristics. So homologous series is that series where they have same functional group, right, and they have similar chemical properties. Examples, you can write alkane series, alkyne, alcohol, or any other series also you can write down. Now list the characteristics. So they have the same general formula, they have same functional group, they differ by a 14U mass, and they differ by CH2 unit. Okay, any 3 properties you can write from here. Next, question number 7, which compounds are called as alkanes, alkenes and alkynes? C4H10 belongs to which of these? Draw 2 structural isomers of this compound. Okay. So alkane means what? Which have saturated hydrocarbon, okay, with single bond. Alkene is unsaturated hydrocarbon with CC double bond. Alkyne is unsaturated with C triple bond C. Okay. Now C4H10 belongs to, if you see the general formula of alkane, it is like CnH2n plus 2. This is CnH2n and this is CnH2n minus 2. Okay. So now what will happen? What is alkane structure? It is C4H10, right? So you can see if I put 4 here, C4, 4 to the 8 plus 2, 10. So this B C4H10 belongs to an alkane. Draw 2 structural isomers of this compound. So if I draw 2 isomers of C4H10, one I can do like this. 1 second. One structure I can draw like this: CH3, CH2, CH2, CH3. Okay, and another structure is like this. Okay, these are 2 structural isomers. Okay, next we'll go to question number 3. A compound X on heating with excess of sulfuric acid at 443 Kelvin gives an unsaturated Y. X also reacts with sodium metal to evolve a colorless gas Z. So identify X, Y and Z. So X definitely is your ethanol, right, because it reacts to give you what? Ethene. So that is, Y is ethene. Okay. Next, what is it giving? It reacts with to produce a gas. So Z is your hydrogen gas. Okay. Next, write the equation of the chemical reaction of formation of Y, and also write the role of concentrated sulfuric acid. So formation of Y, if I have like this CH3 CH2, okay, in presence of concentrated H plus, I will get CH2 double bond CH2. Okay, now what is the role of this one? It is acting as a dehydrating agent. Okay, next let us see question number 9. Why are most carbon compounds poor conductors of electricity? Write the name and structure of a saturated compound in which the carbon atoms are arranged in a ring. Give the number of single bonds present in this compound. Okay, so now you can see the carbon compounds do not conduct electricity because they are covalent in nature. They do not have free ions or electrons. Now there is a structure, saturated compound in which the carbon atoms are arranged in a ring. You can draw like this, cyclohexane. Okay, so here all these are H, right? We can add H here. Okay, next is, so total number of single bonds you can see 6 here, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and 17, 18. Okay, you can draw any other structure as well. Next we'll go to long answer questions here. So how will you convert ethanol to ethene? So ethanol to ethene, how can we convert? It is by using concentrated H2SO4, right? Next, ethanol to ethanoic acid, that is your oxidation reaction by using alkaline KMnO4, right? Now difference between the addition reaction and substitution reaction. So so in addition reaction, what happens? Unsaturated hydrocarbons add hydrogen in the presence of catalyst to give you saturated carbons. And here in case of substitution reaction, what happens? One type of atom or a group of atom takes the place of another in the compound. Okay, now we will see examples here. Okay, if you add hydrogen here, we will get hydrogen here. Okay, next is question number 2. Compare soaps and detergents on the basis of their composition and the cleansing action in hard water. What happens when ethanol is treated with sodium metal? State the behavior of ethanol in this reaction. Draw the structure of cyclohexane and name the following compounds. Okay, so you can see here first what is the difference between soaps and detergents. So all of you know soaps are the potassium salts and detergents are the ammonium or sulfonate salts. Okay, next, this cannot react or cannot be used in case of hard water because they form scum with Ca2 plus and Mg2 plus. They do not form any scum and can be used in the hard water, right? Now question number B we will discuss first. I'll go to the cleansing action later. Now what happens when ethanol is treated with sodium metal? So when ethanol is treated with sodium metal, we get sodium ethoxide and hydrogen gas. Now what is this reaction used for? So this reaction is used as for the test or the presence of the alcohol group, as hydrogen gases evolve during this reaction. Okay, now coming to this question, draw the structure of the following compounds. Butanoic acid. Okay, so butanoic acid structure I think all of you can do. It is like this, CH3, okay, then CH2, then again CH2, then you have COOH. Okay, then you have to draw the structure of chloropentane. So you can draw CH3, CH2. So on the first carbon, what we will do? We will put chlorine. Okay, how the structure? Okay, given below are related to one another. Give reason to justify your answer. Okay, so I think this question is incomplete. The structure is not given. Now differentiate between saturated and unsaturated carbon on the basis of their general formula. So this one we can answer. So what is the formula for saturated carbons? It is CnH2n plus 2, and for unsaturated what is the formula? That is CnH2n minus 2 for alkynes. Okay, and this one is for alkenes. Okay. Now next question, what happens when a small piece of sodium is dropped in the ethanol? Write the reaction for this one. Okay. So if a small piece of sodium is dropped, what will happen? Hydrogen gas will be evolved. So first thing is hydrogen gas is evolved. Okay. Now if you want to write the reaction, it is C2H5OH, okay, plus H2, plus Na will give you 2H5ONa plus H2. Okay. Now what happens when ethanol is heated at 443 Kelvin in the presence of concentrated sulfuric acid in this case? Okay. What happens when ethanol is heated at 443 Kelvin in presence of concentrated H2SO4 in this case? So we know this is your dehydration reaction, right? So what will happen if you heat it with concentrated H2SO4? You will get ethene. Okay. Next, why is glacial acetic called so? So what is the reason for that? Because it freezes at low temperature, right? Next, write the equation showing saponification reaction. So saponification reaction, what is there? That is a salt, right? When a salt is taken in presence of a basic medium, you get what? You get acid and, one second, yes, you get acid, okay, and one second, we have this one, okay, so we will get this acid. Okay, so now in saponification what happens? The ester breaks to give you acid and alcohols, right? So you can write down any reaction like this, for example CH3CO O CH3. Then if you take it saponification reaction, you will get CH3COOH plus CH3OH. Okay. Fine. Next question, it is observed that covalent compounds are bad conductors. You know why? Because they do not have any free electrons, okay, do not have free electrons. Next, carbon can either form C4 cation or anion. This question we have already discussed. Cannot gain because it will difficult for the nucleus, and cannot lose because it will require more energy. Next, draw the electron dot structure of ethanol. So ethanol structure, if you want to draw, you can draw like this ethanol structure, right? One second. So we have two carbons, okay, here there will be bond formation between two carbons, and there will be bond formation between carbon and hydrogen, okay, there will be bond formation between carbon and oxygen, bond formation between oxygen and hydrogen, okay. Just substitute these atoms, CH3, CH2, OH, okay. Here we will have electrons, here electrons, here electrons, here electrons, here electrons, here also electrons, my dear students, here electrons and here electrons, okay. Identify the heteroatom. So heteroatom means different atom other than carbon and oxygen. So here it is oxygen and here it is chlorine. Other than carbon and hydrogen, whichever atoms are present, that is your heteroatoms, okay. Next, what are soaps, and explain the mechanism of cleansing action, and detergents are better than soaps. Why? So what are soaps? First of all, you can write soaps are the sodium or potassium salts of long chain carboxylic acid which has cleansing properties in water. Now this is very important question, mechanism of cleansing, okay. So now why we will answer first this one, why detergents are better? Because they can be used even in hard water, okay. Now cleansing action of soap, you should be writing it in this point only, okay. I have explained you in very detail. So when soap is dissolved, first it forms a colloidal suspension. Next point you need to write that the soap forms Michel structures. Third point, the dirty cloth, the oil part of the grease of the oil part is attracted towards the non-polar end of the Michels, and then when we rub it, the dirt comes out. Okay, that's all you need to write. And here is the structure of the soap, and here it is the Michel action. Okay, these two diagrams also you need to draw. Fine. Next question, write the chemical equation for the following: combustion of methane. So just if I want to write combustion of methane is CH4 plus O2 gives CO2 plus H2O, okay. So we have like I can make it 2. So yeah, like this I'll get, this is 1. Okay, next is balancing of oxidation of ethanol. So we know if we have C2H5OH and you treat it with alkaline KMnO4, okay, ALK, sorry, then you will get CH3COOH. Next, third one is what? Hydrogenation of ethene. So if you have ethene here and you treat it with hydrogen, okay, so you will get 2 hydrogens added here. Okay, next, fourth one is esterification reaction. So in that, if you have one acid, okay, and one alcohol, okay, these two will react to give you esters. Okay, next we have saponification reaction. Just now we note, you can take any ester now, okay, and just treat it with NaOH, you will get carboxylic acid and alcohol, just the opposite of esterification reaction. Okay, so let us see. Okay, so that's all students in this class, and I hope you have enjoyed all the questions, you are able to solve it. If you have any doubt, please comment down, I'll definitely answer to it. Thank you so much students, and see you soon in the next class.